Prompt engineering is an emerging discipline within the world of generative AI, and it describes the art of writing good intentional prompts that produce an output from a generative AI model that we actually want. And to a degree, it is an art. It's very hard to explain how to create a good prompt, but to a larger extent, there's a very logical process and way that we can go into creating prompts that can be described and easily applied to produce better output from large language models and, of course, the generative art tools as well. Good prompts are the key to producing good outputs for these models. Using different types of prompts, we can modify the mode or type of task that is being performed, and we can even use prompts to train models to some degree. And the performance of doing that is actually surprisingly good. Now, there's a few things to learn with prompt engineering, and I think one of the best ways to maybe think about this discipline is to think of it as a more abstract version of programming. So throughout the last decades, we've seen programming languages become more and more abstract. Prompts for AI models is almost like the next step. It's a super abstract programming of an AI model. And that's exactly how I want to approach this here. I want to discuss prompts and building good prompts, the different parts of a prompt and how we apply them to large language models. Now, when we think of large language models, there are a lot of different use cases that they are used for. We see things like creative writing, question answering, text summarization, data extraction, like a ton of these completely different things. And with each of these different tasks, we're not actually doing anything different in terms of the model. The models are all the same for each one of these tasks. The difference is the prompts themselves. Now, what do these prompts look like? Well, we can typically break them apart into a few components. So we have the instructions of a prompt, any external information, or we can also call these contexts quite commonly as well. We would also have the user input or a query, and we can also prime our prompt with what we call an output indicator. And this is usually just a little word at the end. Now, not all prompts require all of these components, but often a good prompt will use one or more of them. So starting with instructions. Instructions tell the model what to do, and this is a very key part of more instruction-based models like OpenAI's Text DaVinci 003. And through these instructions, we try to define what we would like the model to do. And that means how it should use some inputs and how it should format outputs and what it should consider whilst it's going through that process. And we would always put these instructions at the very top of our prompt. I'll explain a little bit more about that pretty soon. Following this, we have our external information or context, and these are additional parts of information that we feed into the model via the prompt. These can be things that we manually insert into the prompt, information that we pull in through a long-term memory component, a vector database, or we get it through other means like a web search API or a calculator API, something along those lines. Following that, we have our user input. Now, that's pretty obvious. That's just the input from a particular user. It depends on what you're doing. Like if you have a text summarization use case, they might input a 2-page chunk of text and we might want to summarize that into a paragraph. Or on the other side, maybe it's a question answering tool, and in that case the user might just type in a few words, question mark, and that is their question, that is their user input. So of course that can vary as well. Then finally we have our output indicator. This is essentially the start of what we would like the model to begin generating. So it's kind of like a way of indicating to the model, hey, okay, now it's time for you to start writing something, and I want you to start writing something based on this first little chunk of text. So a good example, or very clear example, at least in my view, is when you have a code generation model, you want it to generate Python code, you give it instructions to do so, then your output indicator will just be the word import all in lowercase, because most Python scripts will actually begin with the word import, because you're going to be importing your libraries like import numpy and so on. On the other hand, if you were building like a conversational chatbot, this output indicator might be like the name of the chatbot followed by a colon, as if you're sort of in a chat log. Okay, so they're the four main components of a prompt that we're going to talk about and that we're going to actually use to construct our prompts throughout this video. Okay, so let's have a look at an example here. We have the start of our prompt up here. This is the instruction. Okay, so that's right at the top of the prompt. Answer the question based on the context below. If the question cannot be answered using the information provided, answer with I don't know. Okay, so this is a form of conservative Q&A. So given a question, a user question, we want the model to answer based only on information that we can verify. Okay, and that verified information is something that is our external information here, our context. That is also fed into the prompt, right? And we're saying if that information is not contained within this context here, or we'll probably usually have a list of contexts, I want you to say, I don't know. In this case, if the model answers or makes something up, it can lead on to pretty bad results. So we really don't want it to make anything up, because they tend to do that pretty often. So we have our instructions, we have our external information or the context, then we have the user query, which is down here. Okay, so the question, which libraries and model providers offer LLMs? And then we have that final bit, is that output indicator. So this is like, okay, now you can start answering the question. Now this is a pretty good prompt. It's clear. We have our instructions. We have some more external information. We have a question. We have the output indicator at the end now. Okay, so let's have a look at how we will actually implement these things. So we're going to work through this notebook here. If you'd like to follow along and run the notebook yourself, you can do. There'll be a link in the top of the video right now and also in the video description. The first thing we need to do is pip install the OpenAI library. Initially, that's the only library we need. There'll be another one a little bit later on, which I'll explain when we get to it. And we've come down to the first code block. We see we have this prompt. So this is the same one I just went through. So I'm just going to run that and then initialize my OpenAI instance using my OpenAI API key. So if you need this, you can get it from here, which is just at this. So beta.openai.com account API keys, which you can just access. You log into your account, you create a new secret key and just copy that into the notebook. Okay, so once you have authenticated with that, we're going to generate from that prompt that we just created. Okay, so all we do is we go to the completion endpoint, we create. We're using the Text DaVinci 003 model. It's one of the most recent instructional models. And then we print out the response, which will be in this path of the JSON returned. Now here you can see that it stops pretty suddenly here. Now the reason for that is because our max token length isn't very long, and we'll explain that a little bit more later on. But what we first need to do is just increase that length right now. And what we're going to do is just set that to 256. So max tokens equals 256. Okay, and let's just see if that does answer the question. Which libraries and model providers offer large language models? And yeah, that's exactly right. Okay, so we have Hugging Face, OpenAI, and Cohere. Right, and then alternatively, if we do not have the correct information within the context, the model should reply, I don't know, because we have this little bit here. So I'm just going to put in the context libraries are a place full of books, and we would actually hopefully assume that the model is going to put output, I don't know. Now, let me just copy the max tokens again. Put that in here, and we see that it follows our instructions. It says, I don't know. Okay, great. So that's just a simple prompt. Now, what's next? Let's come down here, and what we're going to talk about is the temperature within our completion endpoint. So we can think of the temperature parameter as telling us how random the model can be or how creative the model can be. And it simply represents the probability of the model to choose a word that is not actually the first choice of the model. And this works because when the model is predicting tokens or words, it is actually assigning a probability distribution over all possible words or tokens that it could output. So, say we have all of these different words here, or tokens, I should say, and there are hundreds of thousands of these. It's not six of these. But what we're essentially doing is the model is going through these and it's kind of assigning a probability distribution. So maybe this one has a high probability, this one's low again, this one's kind of big, and this one up here is the most likely one, right? So this is the probability here. And in this case, if we have the temperature set to 0, the word that is going to be chosen is this one here, okay? Because there's no randomness in the model. It's just going to always choose the highest probability token. If instead we turn the temperature up to 1, there is a lot more randomness. It may still choose this token here because it has a highest probability, but it will also consider this because there's still a decent probability there. Okay, and to a lesser extent, it will also consider this bit here, this token, to a lesser degree this one, to a lesser degree this one, and so on, right? So by increasing the temperature, we increase the weighting almost of these other possible tokens as being the selected tokens within the generation of the model. And this will generally lead to more creative or kind of random outputs. So considering this, if we have our conservative fact-based Q&A, we might actually want to turn the temperature down, okay, more towards 0, because we don't want the models to make anything up. We want it to be not creative and just factual. Whereas if the idea is we want to produce some creative writing or some interesting chatbot conversations, then we might turn the temperature up because it will usually produce something more entertaining and interesting and to some degree kind of surprising to see in a good way. So let's take a look at what that might look like. So here we're going to create a conversation with an amusing chatbot. So again, I want to just set I need to add in the match tokens here. Okay, and I'll add that in. So we're going to start, and the temperature is going to be very low. So the default is 1 with the OpenAI completion endpoint. We're going to set it to 0. So the following is a conversation with a funny chatbot. The chatbot's responses are amusing and entertaining. Now, this is like the instructions. Okay, and then down here we have the start of the conversation. We have the user's input here. And then we have our next output indicator. So let's run this and we get this. So, oh, just hanging out and having a good time. What about you? It's pretty predictable. It's not that interesting. It's definitely not funny. It's not amusing or entertaining. Now let's run this again. Last time I got a good answer to this, but it doesn't always provide a good answer. So, we can try. So let me put in the match tokens again. It's a little more interesting. Hang out with my electronic friends. It's always a good time, a bit better. Hang out, contemplating the meaning of life. Okay, so a few better answers. I don't think any of these are as good as the first one I got, but they're not bad. And definitely much better than the first one we have here, which is just, I don't know, a bit kind of plain and boring. So let's move on to what we would call few-shot training for our model. Now, what we'll often find is that sometimes these models don't quite get what we are looking for. And we can actually see that in this example here. So the following is conversation, similar thing again, AI assistant. Assistant is sarcastic, witty, producing creative and funny responses to the user's questions. Here are some examples. And then in here, what we can do is actually put in some examples. But before we do that, I just want to remove that and I want to show you what we get to begin with. So let's run this. We've turned the temperature up, so it should come up with something kind of creative to a degree, but we'll see that it's not particularly interesting. Okay, so yeah, maybe if you want a serious answer, this is what you're looking for, but I'm not asking for anything serious here. I want something sarcastic, witty, creative, and amusing, right? So what if we come down here and we actually add a few examples to our prompt. Okay, so this is what we would refer to as few-shot training. We're adding a few essentially training examples into the prompt. So we're going to say, okay, user, how are you? AI is just kind of being sarcastic. I can't complain. Sometimes I still do. The user will ask, what time is it? And the AI says, it's time to get a watch. Okay, and let's see if we get a less serious answer to what is the meaning of life. Again, let me put in the max tokens. The previous answer was pretty good. I don't know if we're going to get a good one like that again, but let's try. Okay, and we get something good again. As a great philosopher Shrek once said, Fiona, the meaning in life is to find your passion. So kind of useful, but also pretty amusing. So this is a much better response, and we got that by just providing a few examples beforehand. So we did some few-shot training. We showed a few training examples to the model, and all of a sudden it can produce a much better output. Now, next thing I want to talk about is adding multiple context, or adding a context. In maybe I think it was the first example, we had a context in there, but we manually wrote that. Okay, we added that in there. In reality, what we'll do is something slightly different. So let's consider the use case of question answering. Question answering, we want the model to be factual. We don't want it to make things up. And ideally, we would also like the model to be able to source where it's kind of getting this information from. So what we essentially want here is some form of external source of information that we can feed into the model, and we can also use to kind of fact check that what the model is saying is actually true, or is at least coming from somewhere that is reliable. Now, when we are feeding this type of information into a model via the prompt, we would refer to it as source knowledge. And source knowledge, as you might expect, is just any type of knowledge that is fed into the model via the prompt. And this is kind of I don't want to say the opposite, but this is an alternative to what we would call parametric knowledge, which is knowledge that the model has learned during the training process and stores within the model weights themselves. So that's things like if you ask the model who was the first man on the moon, it's probably going to be able to say Neil Armstrong, because it's kind of remembered that from during its training when it's seen tons and tons of human information and data. But if you ask more specific pointed questions, it can sometimes make things up, or it can provide an answer which is kind of generic and not actually that useful. And that's where we would like to use this source knowledge to feed in more useful information. Now, in this example, we're just going to feed in a list of dummy external informations. So in reality, we'd probably use like a search engine API or a long-term memory component rather than just relying on a list like we're doing here. But for the sake of simplicity, this is all we're going to do. So we have a few contexts here. It's talking about large language models, the latest models, using NLP, so on and so on. It also talks about getting your API key from OpenAI. It talks about the OpenAI's API accessible via the OpenAI library, also includes the code. And down here, we also talk about accessing it via the LangChain library. Now, it's going to use all this information, and it's going to use all of that to build a better prompt and create a better output. So what we do is we have our instructions at the top here, as we did before. Then we have our external information, our context. Now, for GPT-3 in particular, what they recommend is that you separate your external information or your context from the rest of the prompt using like 3 of these, or also you can use 3 of these, not like that, but like this. Okay, we're going to stick with these. And then when it comes to the prompts themselves, you also separate them, each one of the unique prompts. So we have one here, and so on. We're separating each one of those with just 2 of these characters as well. Then we have our question, and then we have our output indicator. Now, let me actually just copy this. I'm going to put it up here so we can just see what we're actually building here. We need to run this context here. Now let's run this again. Okay, and I need to print it, otherwise it's a mess. Okay, cool. So still kind of messy, but it works. And also points out to me that I've missed a little bit. So we have the instructions here, and then we have our separator, and then we have our context. Now, actually, here I've got this the thing to separate them, but that's not exactly what we want. We actually want to have some new line characters in there as well. So add those. And to actually do that, we're going to need to separate this bit as well. So put context string in there, and then we also here just put in the context string directly. So come to here, and then we get this sort of nicer format. Just by the way, it will work even if you don't have this nice format, but we should try and format it like this. And so we have our context, and each one of them is separated. Okay, and then you go down, you have a question and the answer at the end there. That is what we want. I'm going to replace this with the context string. And then if we come down to here, I'm also going to add in our max tokens. Great, and let's run that. Okay, cool. So the question, we'll just go up to the top here, answer the question based on the context below, and then answer with I don't know. If it doesn't know the answer, same as before. Give me 2 examples of how to use OpenAI's GPT-3 model using Python from start to finish. Okay, so what we have is 2 options. We can either use it via OpenAI, or we can go via LangChain. Both of these are correct. Now, the one question here is, okay, we added in these contexts, but actually, did it need those? Can we do this prompt without context and still get a decent answer? We can try. So answer the question, and we don't have any context here. Same question, same output indicator. Let's run that. Oh, one thing we all need is the max tokens again. Okay, and yeah, we get this. So using OpenAI's GPT-3 model with Python to generate text. Yeah, that is true, but it's not very useful. And then here it's saying using GPT-3 to generate images, which isn't even possible. So yeah, not really what, not a good answer, essentially. So this is, where we would see our external information, that source knowledge, as actually being pretty useful. Now, considering how big our prompts got with those contexts, and that wasn't even that much information being fed into our prompts, how big is too big? Like, at what point are our prompts too large for us to actually use the model? This is a pretty obviously important thing, because if we go too big, we're going to start throwing errors. So let's begin taking a look at that. So for text DaVinci 003, what we call the context window, which is the maximum number of tokens that text DaVinci 003 can handle within both the prompt and also the completion creation, that is 4,097 tokens. Okay, not words, but tokens. So we can set the maximum completion length of our model as we saw before, where we're setting the max tokens. We can set that, but that cannot cover the 4097, because we need to consider the number of tokens within our prompt as well. The only problem is, how do we measure the number of tokens within our prompt? Okay, so for that, we need to use OpenAI's take token tokenizer, right? So for that, you'll need to pip install take token, taking the earlier prompt, and we'll just stick with the one where I haven't added in the new lines here. Let's take a look at how we can actually measure the number of tokens in there. So we need to import tick token. We create our prompt, hopefully better than using this here. We have our encoder name, which I will explain in a moment. And then we have our tokenizer. So this is the tick token tokenizer, which we initialize by using tick token get encoding. Then we have our encoder name. Encoder name is important for each model here. And then we just tokenizer encode our prompt. Check the length of that. and we get 412. So when feeding this prompt into our text image 003 model, it's going to use 412 of our context window tokens, okay, which is that 4097 that you see here. That leaves us with 3,685 tokens for the completion, okay, for that. So that max tokens, we can set it to that number, but no higher. Now, one important thing to note here is that not all OpenAI models use the P50K base encoder. There is this link here, which will take you through to a table of the different encoders, but in short, as of recording this video, they were this. Okay, so for most GPT-3 models and also GPT-2, you're going to be using the R50K base or GPT-2 encoder. For the code models and the recent instructional models, we use P50K base. And for the embedding model, ADA002, we use CL100K base. So if we now set our maximum tokens to this and generate, let's take a look at what we get. Now, one thing you will note straight away is that the completion time is longer. It's because we have more maximum tokens. Even if it doesn't fill that entire space with tokens, the computational time does take longer. Now, let's see what we have here. It's pretty much the same as what we got before, even though we've increased the number of tokens, because it doesn't need to use all of that space, so the model doesn't. Now, what happens if we increase max tokens by one more, right? So if we go to, you can kind of see already, if we go to 3,686, let's run that, and we get this invalid request error. That's because we've exceeded that maximum content length. So we need to just be very cautious with that. And obviously, like if you're using this in an environment where you might expect the maximum content length to be exceeded, you should probably consider implementing something like this check into your pipeline. Now, that is actually everything for this video. We've just actually been through a fair few things when it comes to building better prompts and how to handle some of the key parameters within your prompt completion inputs. So as I mentioned, prompts are super important, and if you don't get them right, your output is not going to be that great, to be honest. So it's worth spending some time just learning more about prompts, not just what we've covered here, but maybe more, and just especially more than anything, experimenting with your prompts and considering other things depending on what you're doing. Like, do you need to be pulling in more information for your prompts from external sources of information? Do you need to be modifying the temperature? Are there other variables in the completion endpoint that you could do modifying? All these things are pretty important to consider if you're actually building something with any real value using large language models. And another thing to point out is that this is not specific to GPT-3 models. This is if you want to use Cohere's generation endpoints or completion endpoints, or you want to use open source Hugging Face models, like you want to use Bloom or something for completion. You should also consider these prompt engineering like rules of thumb or tricks. Beyond that, I think we've covered everything. So that's it for this video. I hope it's been useful and interesting, but for now we'll leave it there. So thank you very much for watching, and I will see you again in the next one. Bye.